Today we're looking at lesson 6.5, Special Reflections and Rotations. So our objectives today, we have two of them. I can reflect a point across an axis in 1 out of 1 problem, and I can rotate a point around the origin in 1 out of 1 problem. Now, we've already looked at these, right? We've already done some reflections, we've done some rotations, we've done them across axes and not, around the origin and not. But what we're looking at today specifically is some shortcuts you can take, how you can use reasoning rather than trying to memorize rules to figure out what the coordinates of the image are in particular cases of transformations. So we're going to start off looking at the quadrants. So we number the quadrants like this. We start with 1, where both x and y are positive, and then we go counterclockwise. We go this direction, and it counts up 1, 2, 3, 4. And we typically write quadrants in Roman numerals. That's just a convention that's typically used. So let's fill out this table over here. Where is x positive, and where is y positive, or negative? Where is x negative, where is y negative? In which quadrants? So we already said in quadrant 1, they're both positive. How about quadrant 2? Is x positive or negative here? Is y positive or negative here? You can see the x is negative, so I'll just put a minus there, and the y is positive. If we move down to quadrant 3, you can see they're both negative. We have negative x and negative y, so these are both negative. And the last quadrant, quadrant 4, our x is positive and our y is negative. So these are all the possible combinations of positive x's and positive or negative x's and positive or negative y's. And we're going to think in terms of quadrants to help us figure out reflections and rotations quickly. So let's look at special reflections first. Reflections over an axis. We'll start off with an example. We have point D here. Point D is at 3, 2. And we're going to reflect that over the y-axis. Now we may remember that these reflections over the y-axis or over any axis are pretty easy because it's just the same distance away, right? So we know it's 1, 2, 3 over here. Reflection on this side will be 1, 2, 3. And there's our image, D prime. It's asking us what the coordinates of D prime are, so that's negative 3, positive 2, it looks like. And now it says to reflect D over the x-axis. So we're going to do the same process. Let's see, we have 2 down to the x, so we'll go 2 on the other side. There's our new image. I'll call that D double prime. And what are the coordinates of D double prime? Let's see, so our x is 3 and our y is negative 2. So 3, negative 2. All good so far. Maybe you have an idea of where another reflection would be. If we were to reflect either of these 2 points, where do you suppose it would land? There's some maybe symmetry that's showing up here. But also, look at these coordinates. Look at the coordinates of D, D prime, and D double prime. Do you notice anything about these coordinates? Anything, any similarities, any differences? Maybe you noticed that these numbers are all staying the same. The x value, or absolute value, is staying the same. It's a 3 the whole time. And the y absolute value is also staying the same. It's a 2 the whole time. And if we were to draw our 4th point over here, our next reflection, it would be negative 3, negative 2. It follows that same pattern. The x stays 3, the y stays 2. All we're doing is we're changing up where the negative signs are. So in general, when you reflect a point over an axis, all these numbers stay the same. The x number stays the same, the y number stays the same. The only thing that changes with each reflection is one of the signs. You can see this 3 became a negative 3, this 2 became a negative 2, and then this 3 becomes a negative 3 over here. So the numbers stay the same, but one sign changes. So we can use reasoning about quadrants, about what we know about the positive and negative values in quadrants. This is a negative positive, this is negative negative, this is positive negative. We can use that information to reason out what the result will be after a reflection over an axis. So we're going to start with which quadrant is our original point in? Which quadrant do we start in? Which quadrant do we end in after the reflection? We can figure that out by determining where the reflection went, which axis it was over. And then we look at that end quadrant and we say, what are the signs in that quadrant? Are they negative positive? Are they negative negative? Are they positive positive? Whatever those signs are, we're just going to assign the end quadrant signs to the point values. And if we use this method, we don't even necessarily need a picture. So let's check out how that might work. So for example, we might want to reflect point E at 7, 4 across the x-axis. Now they haven't given us a picture, but we can think about this. We think, what quadrant is this point in? They're both positive. So it's our positive, positive quadrant. It's quadrant 1. And if we were to reflect that over the x-axis, right, we started here and we reflected down here. We end up in quadrant 4, where we have positive x, negative y. So all we do is we look at our original points, 7 and 4, and we say positive x, negative y. So our answer will be 7, negative 4. Pretty easy, huh? Pretty slick. Let's try another one. Reflect point F at negative 6, 2 across the x-axis. We're going to ask, what quadrant do we start in, and then what quadrant do we end in? What do you think? So our x value is negative, and our y value is positive. That's this quadrant. X value is negative, y is positive, so that's quadrant 2. And we're going to go across the x-axis. That puts us in quadrant 3, where our x values are negative and our y values are negative. So we'll take those same numbers up there, 6 and 2. We say our x value is negative, our y value is negative, and that will be our answer. One more. Reflect point G at negative 1, negative 4 across the y-axis. What are the coordinates of our image G prime? What quadrant do we start in? Both x and y values are positive or negative? They're both negative, which means we're in quadrant 3. We're going to go across the y-axis this time and end in quadrant 4. In quadrant 4, we have positive x values and negative y values. So positive x, negative y, we'll apply them to those original numbers we had, 1 and 4. So we get a positive 1 and a negative 4. All right, that's everything on special reflections. So let's move on to special rotations now. 90-degree rotations around the origin. So here it asks us to rotate point M, which is at 4, 1, 90 degrees counterclockwise about the origin. What are the coordinates of M prime? So counterclockwise, remember a clock goes this way. 12, 1, 2, 3, so that's clockwise. So we're going to go the other way. We're going to go counterclockwise. So it sounds like we're going to go this direction. And we have a few methods of looking at this. We turned our head to the side maybe, or we thought about rotating the entire quadrant over this way. Where would this point end up? It needs to be the same distance away from that center, from the origin. With any of those methods, we might come up with this point up here, which is negative 1, positive 4. So that is a 90-degree rotation. And now it says rotate M 180 degrees counterclockwise about the origin. So that would be just another 90 degrees, right? We went 90 here, we'll go 90 again to get to 180. And you can use the same methods. turn your head, or imagine rotating the entire quadrant, and we get a point right there. Those coordinates are -4, -1. So again, it looks like we might be forming a pattern here. You might have a guess about where our fourth rotation might land, or it's actually our third rotation, but our fourth point. But let's look at the point's coordinates. Do you notice anything similar about the coordinates here among m, m prime, and m double prime? Do you notice anything similar? Maybe some differences? Maybe you might have a guess about what m triple prime's coordinates would be? Maybe you noticed that all of these involve the same two numbers, absolute values. We see 1 and we see 4, but we don't see any other absolute values, just 1 and 4. And you also may have noticed that they were swapping places. We have 4, 1, then 1, 4, then 4, 1. So maybe we'll swap 1 and 4 again. And then the other change is that one of them is turning negative each time. So notice this is Q1, we have two positives. Q2, our x is negative and our y is positive. Q3, both are negative. So for Q4, we might think x is positive, y is negative. So notice if we graph that now, 1, -4, it does continue this pattern. And it looks, if I were to draw that straight, it looks like our axes just kind of rotated a little bit. They kind of shifted. So we can generalize this rule saying that when we rotate 90 degrees around the origin, one sign changes just like in reflections, but also the x and y swap. And that's going to happen each time we go 90 degrees. So for that step, for this step, and for this step. Each time we do that, one sign changes and the x and y swap. So how we're going to rapidly evaluate this is very similar to how we do reflections. The only main difference is that we have to figure out the x and y swapping piece. So here are our steps. We're going to ask again, what quadrant do we start in? Then we figure out what quadrant we end in based on how many 90 degrees we have, how many steps. We swap the x and the y for each 90 degrees, and then we set the signs by the end quadrant. Incidentally, just thinking about this step, the swapping x and y, remember how we said you can think of taking a whole quadrant like this, taking quadrant 1, and rotating it up on its side when we go 90 degrees. We said you can rotate this part up and this part comes down so that the whole quadrant moves over. But think about what that means. We're literally saying the x-axis becomes the y-axis, and the y-axis becomes the x-axis. That's why we swap the x and y, because we are literally rotating the point so that the x and y swap. And then we just end up in a different quadrant, so we have to assign positive or negative values. So let's see this in action. Once again, we're not getting pictures for this. We have to imagine this in our own head, or we can sketch it out. That can help us see the quadrants. It says rotate point N at 4, -5, 270 degrees counterclockwise about the origin. Okay, first of all, counterclockwise, I have to draw a clock sometimes. Clock goes that way, so we're going this way, counterclockwise. And then we need to figure out the coordinates of n prime. All right, so how many quadrants is 270? How many 90-degree rotations is that? So we have 90, 180, 270. So this sounds like 3 rotations. So let's figure out where we start out. 4, -5, so that's 4 is positive, -5 is down here. So we're in quadrant 4 when we start out. And we're going to take 3 rotations counterclockwise. So here we go. 1, 2, 3. We end up in quadrant 3. Now we also know we need to switch these coordinates 3 times. So here we go. 1, 2, 3. And our last step is to assign the values, assign the positive and negative values based on the ending quadrant. We ended in quadrant 3, which is negative x, negative y. So these will be negative 5 and negative 4. That's our answer. Now another way you may have thought of this that is also valid and even quicker is you could have said to yourself, well, 270 counterclockwise, that is equivalent to 90 degrees clockwise. That's the same transformation. Instead of going 3 that way, you could have gone 1 this way and ended up in the same place. Notice if we do that, we still have an end quadrant in quadrant 3, but now we're only doing 1 rotation, which means we only swap once, and we still end up with 5, 4. We say 2 negatives in quadrant 3, so negative 5, negative 4, and we're done. So if that occurs to you, that is totally a valid thing you can do too. Because going around and around a circle, you do end up in the same place. So you can always go the other direction, the 360 degrees minus that amount. So 360 minus 270 is 90. So we could go 90 this way, or we could go 270 this way, and we end up in the same place. All right, that was a lot of information on that one. We're trying to make this easy, right? Let's do another one. Let's just get back to making this easy. All right. Rotate point P, negative 4, negative 2, 180 degrees clockwise about the origin. What are the coordinates of P prime? So let's think about the steps we need to do. We need to figure out the starting quadrant. A negative and negative is quadrant 3. We're going to go 180 degrees clockwise. Clockwise is this way. So there's a 90 and a 90, right? 90 plus 90 is 180. We end up in quadrant 1. And then we know that we need to switch these twice. So swap, swap. Both of them are positive in quadrant 1, so that is our answer, 4, 2. Notice because 180 is exactly half of a circle, we could have gone the other direction and it wouldn't have made any difference. 90 this way and 90 this way, we end up in the same place. All right, one more example. Rotate point Q, 1, 3, 90 degrees clockwise about the origin. What are the coordinates of Q prime? So we'll start off in quadrant 1. And that's all the hint I'm going to give you right now. Pause the video, see if you can figure out what our answer is here. If you were to rotate point Q 90 degrees clockwise about the origin, where would you end up? All right, let's see if we get the same answer. We start at 1, 3 in quadrant 1. We're going to go 90 degrees clockwise, which is this way. We end in quadrant 4, where x is positive and y is negative. And we know that for each 90 degrees, we need to swap once. So this is a 1 rotation transformation. So we're just going to swap these once. 3, 1. We have a positive x and a negative y. So our solution here is 3, negative 1. So what are the missing steps? We just used these steps for fast calculations of reflections across an axis and 90-degree rotations around an origin. What steps are we missing here? So we had a start quadrant, then we needed to evaluate the end quadrant. And based on the end quadrant, we set the signs. That's all we had to do with our special reflection. How about 90-degree rotations around the origin? What 2 steps are missing here? Take a look. We evaluate the start quadrant. Just like in reflections, we also evaluate the end quadrant, so we can set the signs. We figure out how many rotations to get there. And then we had one special step for 90-degree rotations that we didn't do in reflections. Do you remember the special step? It kind of involved rotating that entire quadrant, something about the x's and the y's. We needed to swap the x and the y values for each 90-degree rotation. So that wraps up our objectives today. I can reflect a point across an axis in 1 out of 1 problem, which we could do already, but we just have a shortcut now. And I can rotate a point around the origin in 1 out of 1 problem.